Hi guys, so today we're going to be talking about statistical measures. You've seen some statistical measures before, so we're just going to be building off of that, and really we're just going to be adding something new, which is known as variance and standard deviation. Okay? Before we get started with our examples, let's look at some definitions. Okay? So data with one variable, such as things like test scores, are known as univariate data, right? Uni meaning one, variate variable. So univariate, one variable data. Okay? Sometimes it's convenient to have a number that kind of describes a set of data, which you've looked at before, such as mean, median, mode, range, etc. Okay? And so this, sometimes what we want is this number is known as a measure of central tendency. And what it means is it represents the center or the middle of the data, right? Central, center. So it's a way to measure the center of our data. Okay? So the most commonly used measures of central tendency you've learned before is the mean, median, and mode, right? So here, mean we know as average. Okay? Mean we know as average oftentimes, right? We add up all the numbers and then divided by the amount of numbers we added together. Okay. Median is the middle number, right? And then mode is the number that appears the most often. Right? So sometimes, depending on what we want to use with the data, we decide which measure of central tendency to use to represent it, right? So for example, when the data is all spread out, what we want is we want an average of the values, and so then we would use mean. Okay? When we have data that contains some outliers, what we want is the median. Okay? And then when there are data that is tightly clustered around one or two values, then we would want the mode. Okay? So let's take a look at example 1. Okay? So a sweepstakes offers a first prize of $10,000. Okay? There are 2 second prizes that are $100, and then there's 100 of these third prizes worth only $10. Okay? Which measure of central tendency best represents the available prizes? Okay? So here, the mode represents the available prizes best. The available prizes best. Okay? Note why, right? We could have chosen median as well, right? Mode, so mode is because $10 shows up the most, right? There's 100 of those compared to only 2 of the hundreds and only 1 of the 10,000s, right? The mode is what happens the most, okay? Note that for your median, it will also be $10, right? But to say that that's the middle, it's true, but it's kind of misleading, right? And then if we do average, because 10,000 is so much above 10, it will push the average to be higher up than it really is, right? So some ways we've often had discussions with us math teachers about what we mean by average, right? And so in this case, if we talk about the average in terms of mean, it's gonna, because of this is so much higher, it's gonna push it above the $10, right, towards the 10,000 end, above the $10, when in reality, most people aren't getting $10,000 or even close to this, right? Most people, if they win a prize at all, is really just going to get $10, right? And so that's why the most often thing that pops up, the mode, represents best the available prizes. Okay? Which measure of central tendency would the organizers of the sweepstakes be most likely to use in their advertising? Right? So if you were advertising this so that people would sign up, what you would actually do is you would probably choose the mean. Okay? Okay. The reason why is because if you actually did the math for all of it, the mean is about $109. Okay? And so if you were saying that the mean or the average of people are going to win $109, what you're going to say is you're going to make people think they had a better chance of winning more money. Because if you use the mode and you said, oh, most people are going to win $10, they're probably not going to go through all that work of signing up for this sweepstakes, right? But if you told people, hey, the mean or the average of amounts of winning is 109, then people are going to think, I mean, what you said is true, right? But it gives people this false understanding or this false, like this misconception that they're actually going to win more money when the reality is that's probably not true, right? And so that's why, depending on what kind of purpose you're using the data for, that's going to affect which measure you use, which measure you advertise, which measure you tell people about, right? And that's why it's important when you're looking at articles or whatever that use statistics and what it means, that you really understand what it's saying, right? Because it could be true, right? But the way they say it and the number they chose to give you is definitely leading you down some type of purpose. It has a purpose. It has a message that it wants you to believe. Right? Okay. Before we get to our next and last example, which will be new to us on standard deviation, let's talk about some definitions. Okay. So measure of central tendency kind of talks about the center or the middle of the data, but measures of variation or dispersion measure how spread out or scattered a set of data is, right? The simplest measure of variation that we use, which you've done before in previous math classes, is range, right? And what range is just the greatest minus the least value to see how far apart they are, okay? Variance and standard deviation, those are new to us, are measures of variation that indicate how much the data values differ from the mean, right? So what it does is it measures how far each of the numbers is in comparison to our average. Okay? So to find the variance, it's represented by this. Okay? You follow these steps. First, you need to find the mean, the average, right? Which is to add up all the numbers and then divide by the amount of numbers you have. It's represented by this X with a bar over it. Okay? And then what you're going to do is you're going to find the difference between each value in the set of data and the mean, right? So basically, you're going to take each number minus your average, and then you're going to square it. Okay? And then you're going to take your next one minus your average, and then square it. Take the next one minus your average, and then square it. Take your next one minus the average, and then square it. Okay? Then you're going to add all of those up, all of those differences up, and divide it by how many there are. So that's what it means by find the mean of the squares. The standard deviation is just the square root of the variance. Okay? So that's where it is, right? So note here, this is the mean, right? So you're taking each value, minusing the mean, you're squaring it, right? Each value minus the mean, squaring it. Each value minus the mean, squaring it. Then you're finding the average of it, so that's why you're adding each of them up, divide by how many you have, and then for standard deviation, then you're going to square root it also. Okay. So let's get started. It's going to take some space. So standard deviation isn't hard. It's just a little bit more tedious. Okay. So here, this table shows the population in millions of 11 eastern states as of the 2000 census. Okay. We want to find the variance and the standard deviation of the data to the nearest tenth. Okay. So what we're going to do is we're going to first start by finding the average. Okay. So we're going to find the average, or the mean. Okay. So what I'm going to do is I'm going to add all of these up and then divide by 11 because there's 11 of them. So 19.0 plus 12.3 plus 8.4 plus 6.3 plus 5.3 plus 3.4 plus 1.3 plus 1.2 plus 1.0 plus 0.8 plus 0.6. Okay. all divided by, there's 11 of them, divided by 11. Okay. Okay. And then this gives me 5.418, and then the 18 repeats forever and ever and ever. Okay, so now we're going to find the variance. Okay, so we might want to just approximate it to about 5.4 million people. Okay, so it's not going to be as accurate, but since the book doesn't mind, we're just going to round it. So it's about 5.4 million people is the average in each state. Okay, so step 2, we're now going to find the variance. Okay, so that's this squared. Okay. So basically, we're going to run out of space. Okay, but basically, oh, I should not have my square. I'm going to remove this. Sorry about that. Okay. Basically, what we're going to do is we're going to take each of these, subtract it by this, the average, right? Because the whole point of standard deviation and variance is to show how far this is from the mean, right? So that's why we're subtracting it from the mean. So we're going to start with 19.0 minus 5.4, and then we're going to square it. Right? And we're going to do 12.3 minus the average, and then square it. Okay? Then we're going to, so I'm going to keep going, 8.4 minus the mean, and then square it. Okay? And then 6.3 minus 5.4, and then square it. Okay? And then add, so I just left out 6.3. So next one is 5.3 minus 5.4, and then I'm going to square it. And then I'm going to do 3.4 minus 5.4, and then square it. And then next one after that is 1.3 minus 5.4, and then square it. And then 1.2 minus 5.4, and then square it. Still not done, right? So it's not hard. 1.0 minus 5.4, and then square it. And the next one is 0.8 minus 5.4, and then square it. And then last 0.6 minus 5.4, and then square it. And then I want all of this added together, right? And then I'm going to divide it by however many there are. And so in this case, there are 11. Right? And so then this, what it gives me is it's approximately 31.3. Right? So that's what the variance is. Right, so this is the variance. Okay. And then so then the standard deviation, which is represented by this, is going to be the square root of the variance. So, square root of the 31.3 is approximately 5.6 million people. Right, so this is the standard deviation. And there you go. Right? So it's not hard, just actually entering each of them and then making sure you don't make a mistake. That might be a little bit harder, right? So I would make sure, right, your calculator doesn't know order of operations, so make sure the parentheses are in the right places and things like that so it does it correctly. Okay. Eventually, if you did a statistics class, you can do it on the graphing calculator. If you want to kind of see how you do that, you can look on page 719 on how to do it on a graphing calculator. But at least for now, I want you to understand how we get it, right? Because the idea of this variance and standard deviation is how far apart your numbers are from your average, right? So understanding that we get this by subtracting our average to find the difference of them, that's important, okay? So why don't you try CYP2, and then once you're done, come check the answer. Okay, so for the variance, you should have gotten approximately 87.9, and for the standard deviation, you should have gotten approximately 9.4. Okay? If you got that right, you can get started on your homework. If not, here is your explanation. Okay? So I highly suggest maybe instead of even using your scientific calculator, I would probably use Desmos. their scientific calculator, that might make it a little bit easier. Okay, so again, remember that variance and standard deviation measures how far your values are from the mean, right, from the average. And so I would start by finding the average, right? So we're going to add up all our numbers and divide by how many numbers we have, right? So 43, 50, 52, 56, 70, 65, 50, 73, 57, 47, 48, all added together, divide by 11. Okay. This gives you 55.54, and the 54 just repeats. Okay. Then, with that in mind, I'm going to now find the variance. Okay. And so what I do with that is I take each of these numbers, okay, and I'm going to subtract it by this average, the mean, and then square it, right? So that's why I did 43 minus this, and then squared it. Then plus this minus the mean, and then squared it. Plus this minus the mean, and then squared it. And then etc., 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 right? So here, again, it's not hard. The difficult part is really making sure that you enter it into the calculator correctly, right? And so that's why I think doing it with the Desmos calculator makes it a little bit easier. Okay. It's also important that you have parentheses where they should be, right? Because you don't want it to accidentally square everything that happened before. You want it only to square what you have here, which is each of the values minus the mean, okay? And then you're finding the average of that, so that's why you're dividing by 11, and then there you go. And then standard deviation is just the square root of the variance. So once I have the variance, I just need to square root it, and that gives me the standard deviation. Okay? So that's it for today. Have a great rest of the day. Bye, guys.